Okay, welcome back to our video of today. We are going to explain something on linear substitution, just as I said earlier in the previous video, where we were seeing we were making substitution whereas the constant of integration was 0. So today you'll realize that our constant 1 is -1, our constant 2 positive 7. So automatically you can't apply the first video. So the first thing here, we are going to cross multiply such that I'll have x plus 2y minus 1, everything here being multiplied by dx should be the same as x plus 2y plus 7, everything multiplied by dy. So I want to equate my equation to 0. So that is the same as saying x plus 2y minus 1, this is dx, minus x plus 2y plus 7, this is dy, everything gives us 0. So up to this point, what we are now going to do, because when I name this one my a1, my b1, a2, my b2, so you'll realize that when I take my a1, b2 is the same as a2, a2, b2. So a2, b1. So what we do here, what we are going to do here, we make use of a u substitution. So I'll let u to represent x plus 2y, because you realize here I have x plus 2y, the same I have the other side. So after finding u to be equal to x plus 2y, what do? We find the derivative of u, the du, and the du will be, when I integrate this x with respect to du, I'm going to get dx, or 1 dx, which is just the same as dx, plus when I integrate this one with respect to u, I'll get 2 dy. So I'll just now replace my values such that I have x plus 2y minus 1, which is the same as u minus 1 multiplied by dx. So I make dx the subject from this particular point, such that my dx now will be the same as du minus 2 dy. This dx is here, so I've just removed this 2 dy to be to the other side, so that I have du minus 2 dy. So when I am now at my second level, where I'm saying u minus 1 dx, so my dx this time around is du minus 2 dy. I'm multiplying, then I'm subtracting everything from x plus 2y, and this was, we said, was the same as our u plus 7, and this time around it is our dy. This time is our dy. So what do I do at this point? At this point, I just open my brackets here. So to open bracket, I have u minus 1 multiplied by du, then minus u minus 1, it is minus because of this negative at this particular point, multiply by 2 dy, then again minus u plus 7 multiplied by dy. So I've bring the dy's, I want to bring the dy's together so that I factorize whatever I have inside the bracket. So it's like saying u minus 1 du minus bracket, I take this u minus 1, but at this time it is multiplied by 2, so it is just 2u minus 2 because it is multiplied by 2, minus this u, then when I open this bracket, I have minus 7, and everything is multiplied by dy because I've already used that to open the bracket. So at this particular point is just u minus 1 du minus 2u minus u is just minus u. 2u minus u is just u, minus 2 minus 7 is minus 9, and this is dy, and everything here we should equate it to 0. Everything we should equate to 0. So this is like saying u minus 1 over u minus 9 du minus dy equals to 0. So how, somebody may be asking him or herself that how have I written at this point? You realize that I can directly divide here by u minus 9 by u minus 9 without necessarily changing the sign, because when my u minus 9 crosses the other side, it is negative, so it will become positive. So when I'll be dividing and again return dy the other side, it will remain minus. And as I said earlier, ODE is always all about integration, so we will integrate both sides. So you will realize from our integral calculus that whenever I have u minus 1 over u minus 9 du, so I want to integrate this particular equation. How am I going about it? So here we just use the long substitution because we can't use the u substitution, so we apply the long division method, such that for applying a long substitution method, I'll have my u minus 9 into u minus 1. So I'll say u goes to u 1 times u is just u minus 9. So everything that is remaining there is 8, because 1 minus negative 9 is 8, such that whatever I'm now having at this particular point is 1 plus 8 over u minus 9. 1 plus 8 over u plus 9. So this is the same as integrating 1 with respect to du plus 8 over u minus 9 with respect to du is minus dy, integral of dy, and this is the same as integral of 0. So you know very well that when you integrate u, 1 we get u plus, this is the same as 8 ln of u minus 9 minus dy. When you integrate dy is just y, and this one should give us some constant of integration c1. Good, constant of integration c1. But remember, our u we equate it to be x plus 2, so it is just the same as x plus 2y plus 8 ln u x plus 2y minus 9, and that one I'll put in bracket minus y is equals to c1. Thank you. Let us meet in our next video.